Now let's look at this truss. Checkin na natin ngayon yung determinacy. So maglagay tayo dito ng pin and then roller support. So how many members? 1, 2, 3, 4, 5, 6, 7, 8. Top chord 1, 2, 3, 4, 5, 6. Plus webs 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So 21. Then how many joints? Hello? How many joints? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now let's look at M plus R. Is equal to 2J. Okay. So 21. How many R? Dito, you have vertical, horizontal. Dito, vertical lang. Wala kang horizontal since it is roller support. So R is 3. So M plus R will give you 24. And then 2J is also 24. So therefore, it is determinate. Next. Lagyan na natin ngayon ng isa pang roller support dito. Okay? So your reaction now becomes 4. So this becomes now 21 plus 4 magiging 25. It is now greater than 2J. So therefore, it is indeterminate. Yan. Kapag indeterminate na ang ating figure, magkukulang na yung equilibrium conditions mo. Summation forces X, summation forces Y, summation forces Z, medyo magkukulang na yun. Magdadagdag ka na ng summation moment is equal to 0 para ma-solve mo yung buong structure na yan. Okay, next is, gawin natin, let's say, gawin natin itong roller. Yan. So, vertical lang yan. Wala siyang horizontal. So, your R here becomes 3. Okay? So, 21 plus 3 becomes 24. It becomes determinate, but geometrically unstable. Yan. Stable siya in the sense na panay horizontal loads lang ang given, hindi siya gagalaw along X. Pero pag once na naglagay ka na ng slight horizontal, magmo-move na yan forever along the horizon. Now let's go to determinacy and stability of rigid frames. Ang pinag-usapan natin dito ay determinate and indeterminate. Anong pinagkaiba nung dalawa? Unang-una, yung determinate, madali lang siyang isolve. Yung indeterminate, mas mahirap siyang isolve. Okay? Kailangan mo ng mas maraming equations sa indeterminate. Kailangan mo ditong mag-simultaneous equations or gagamit ka na ng mga matrices. Another thing is, in the old curriculum, meron tayong Curie 1 tsaka Curie 2. Yung Curie 1, yan yung determinate. Yung Curie 2, yan na yung indeterminate. Ganun lang kasimple yun. Pero sa curriculum natin ngayon, pinagsama na yung dalawa. Okay? So, now let's go back to rigid frames. Remember that a rigid frame is composed of beams and columns connected rigidly at the joints. Let's take the word connected rigidly at the joints, such as the one shown in this figure. So let's take an example. Yung figure kanina. Okay, so fixed, fixed, fixed. What will happen if I apply a load here? or mag-apply tayo ng load na horizontal. Okay? So, magde-deflect yan, something like this. Since fixed dito, your rotation or angle of rotation is 0. So, magiging ganyan, magiging ganun, then ganyan. What will happen here? It will be something like this. Ganyan ulit. Tapos, ganyan pa rin siya. And something like that ang kanyang displacements. Okay? Okay, so for a frame to be determinate, for a frame to be determinate, for a frame to be determinate, 3m plus r should be equal to 3j plus c. If greater than, it is indeterminate. If less than, unstable. Okay? So, this is determinate. If greater than, it is indeterminate. If less than, it is unstable or it is a mechanism. Remember na C is equal to 1 for hinge and C is equal to 2 for roller. If none, then it is 0. So let's take this example. Yan, so pinned. Your M is equal to 3. How many reactions? 6. So this is vertical, horizontal, and then moment. Dito naman, vertical, horizontal, and still you have moment. So reaction is 6. And then how many joints? You have 4. 1, 2, 3, 4. And your C is equal to 0. So let's take the equation. 3m plus r is equal to 3j plus 0. Okay, so 15. 3 times 3, 9 plus 6, 15 is greater than 12. Okay, so therefore, indeterminate. Oh no. Now let's look at this case, for example. So meron tayong beam, tapos meron tayong column, pero isang support na lang siya. So obviously we have here 3 members. Support is 3, vertical, horizontal, tsaka moment. And then joint, you have 4 joints, 1, 2, 3, 4. So using this equation again, 3m plus r is equal to 3j plus c. 3 times m plus r is equal to 3j plus c. So this becomes now 12 is equal to 12. Therefore, this is now determinate. So, what more? Kung ang figure mo ay ganyan, di ba? Kahit gawin mo yan na pin, any figure, basta beams and columns, magiging indeterminate na siya. So let's take this example. So how many members? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. How many reactions? You have 2, 4, 6. Tatlong vertical, tatlong horizontal. And then how many joints? You have 3, 6, 8 joints. So 3m plus r is equal to 3j plus 0. So 8 times 3, 24 plus 6, 30 is greater than 24. So obviously this is indeterminate. Okay? So lahat ng karamihan or lahat ng frame structures or rigid frames, it is obviously indeterminate. Mahirap mag-solve dyan, kaya gagamitin natin mga approximate methods para ma-solve mo yan. Pero, kapag exact ang gagamitin mo para sa buildings, ang kailangan dyan ay stiffness matrix methods na. Okay? Yun ang mahirap, stiffness matrix method. Okay, so our next topic still at chapter 2 would be solving reactions and moments, but we will take that up later on. So for now, that ends our lecture. But it's not over yet. Mag-recap tayo. Wala nang recap. Recap mong mukha mo. Okay, class? Thank you very much and have a safe week ahead. Bye. Okay? So merong mga figures na determinate, indeterminate, but it is geometrically unstable. Now let's go to stability and determinacy of trusses. A simple rigid truss is formed by starting with a triangle consisting of 3 members and 3 joints. So, member 1, member 2, member 3, then 3 joints, 1, 2, 3. And subsequently adding 2 members and a joint to form another triangle. So, 2 members, 1, 2, tsaka isang joint. This addition of 2 members and a joint is continued until the final truss configuration is attained. Remember na laging 2 members and isang joint. So, 1, 2, isang joint. 1, 2, isang joint. Okay? Tapos, 1, 2, isang joint. Still, this is a truss. A truss with J joints will require J minus 3 additional joints to expand the structure beyond the original 3 joint triangle. Since each additional joint is formed by the intersection of 2 members, the total number of members M to form a simple rigid truss is M is equal to 2J minus 3 plus 3, or this is simply 2J minus 3. Now, M is simply the number of members. Tapos J, this is the number of joints. Now let's look at our example. Okay, M number of members, J number of joints. How many members? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So M is 11, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many joints? 1, 2, 3, 4, 5, 6, 7. Now let's look at the said equation. M, according to this equation, M is equal to 2J minus 3. Let's check. So, what is the value of M? I think 11. 1, 2, 3, 4, 5, 6. Okay, so 11. How many joints? 7. They should be equal. 11 is equal to 14 minus 3 equals 11. So, check ang ating figure na truss. Let's take another example na truss. Yan. So, how many members? Mag-start tayo sa baba, bottom chord. 1, 2, 3, 4. Tapos sa top chord, yung taas, 1, 2, 3, 4. Plus yung webs, 1, 2, 3, 4, 5. Okay, all in all, you have 13. Tapos yung number of joints naman. So, start tayo sa bottom chord, 1, 2, 3, 4, 5. Plus sa top chord, 1, 2, 3. You have 8. So, let's check again the equation na M is equal to 2J minus 3. Yan ang equation mo to qualify as a truss. So, 13 is equal to 2 times 8 minus 3. So, 16 minus 3 will give you 13. Okay, so it qualifies as a truss. Remember that this is your equation to qualify a structure as a trust. Next, another example is, check natin ito. Yan, no? So, how many members? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so bottom chord 1, 2, 3, top chord 5, 6, 7, 8, and then webs 9, 10, split 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yan. And how many joints? 1, 2, 3, 4, 5, 6, 7. Let's check using this equation. So member is 10 is equal to 2 joints minus 3. So 14 minus 3, 10 is not equal to 11. So therefore, okay, so therefore, this equation does not satisfy your truss equation. So therefore, this is not a truss. Okay, this is not a truss. Let's continue. If m plus r is equal to 2j, the truss is determinate. If m plus r is greater than 2j, statically indeterminate. If m plus r is less than 2j, the truss is unstable. Now let's look at these figures A, B, C, and D. Initially, by visual inspection alone, kapag merong square sa loob, hindi na ito, possible na hindi na ito truss. Okay? Like for example, ito. Mache-check natin yan mamaya kung truss siya or hindi truss, stable or unstable, determinate or indeterminate, or mechanism. Now let's look at figure A. So you have M is equal to 9 or 9 members. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many reactions? Tatlo lang. So vertical, vertical, vertical. Wala siyang horizontal. Ano? So meaning, gagalaw siya forever horizontally. It is geometrically unstable. Next is, let us check ito, yung equations. M plus R and 2J. So, M plus R, this becomes now 12. And then, 2J now becomes 12. So, equal sila pareho. If equal, the truss is statically determinate. So, this is statically determinate, but geometrically unstable. Now, let's look at letter B. Your M plus R would be 12. And then, 2J is also 12. Again, it is statically determinate, but geometrically unstable. Now, let's look at letter C. Your M plus R would be 12. Again, 2J is 12. How about here? Note na ang reactions mo dito, they are also concurrent. Yan, nag-meet sila sa point O. So, ang reactions niya dito ay tatlo rin. Now, let's check the number of members. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many joints? You have 6 joints. 1, 2, 3, 4, 5, 6. So, M plus R, this is again 12. 2J is also 12. And, let's check if this figure meets the criterion na M is equal to 2J minus 3. So, your M is 9. And then, 12 minus 3 is also 9. So, they qualify as a truss. Okay? So, this is still a truss. Ang tawag dyan ay compound truss. So, any truss na meron ka nang nakitang square or rectangle sa loob, ang tawag doon ay compound truss.